What I'd like to do is review some specifics about Module 3, the resources that I've posted, and a workaround for the host systems. Yesterday, the virtual machines on the campus, all of them, were powered off. And so I did not get a chance, to work on, I'm not sure what happened, but I did get a notice from at least one student that there were virtual machine issues. And when I went to check in this morning to see what was going on, all of the host systems are offline. So it's not just the virtual machines, everything's out. It could be a service outage with the data, the connection to the internet, or it could be power outage. I think during the holiday yesterday, maintenance may have decided to do some things. So one of our goals today is to discuss what you can do for a practical workaround so you can continue with the assignment and the solution. So one of the things we want to do is just to quickly walk through some of the new resources before we get started with the alternative measures. So you see here, you have Windows subsystem for Linux set up, and that was due by 11 a.m. But that's since been changed to 11:59 p.m. tomorrow. So I'll show you on the 4th, 11:59 p.m. So I guess I'll change the header for that to match. Are there any questions? Because we had the outage and people couldn't get to the stuff. Any questions?
No questions.
Okay. So one of the things that we want to call out about this Windows subsystem for Linux is the built-in capacity for the Windows operating system. You know, they love to extend everything, don't they? So when you look at the philosophy that they have for the design, the ultimate design of their operating system, the operating system is not terribly efficient at any one thing. It's not finely tuned to be a great web server or a great file server. It's designed to do anything and everything anyone needs. And so in the throw in the kitchen sink category, if you wanted to integrate Linux with your enterprise environment in order to extend enterprise file system objects and accessibility for all of the operating systems, you know, that are operating in your workplace, basically this kind of takes the cake. So starting with Server 2016, Microsoft decided that they were going to support Linux virtual machines in their Hyper-V virtual machine environment. So they have a solution that's like VirtualBox, or it's like VMware. It's called Hyper-V, and you can support and run virtual machines. You probably already know this. We've probably already discussed this. One of the things we need to be able to do is to incorporate and integrate other kinds of operating systems in enterprise environments and extend the operating system, specifically the file system attributes, so that they can operate in very productive and powerful ways. So the whole idea of RBAC is not exclusive to Windows. The important thing to understand is that our solution for this module involves a setup of Active Directory integrated Linux. And we can simulate that with Windows subsystem for Linux, even if we're not using the virtual machines online. We can simulate that process and complete that activity using the server that you have on your local laptop. So hopefully all of you still have your Server 2019 installation in VirtualBox. Is there anyone at this time that doesn't have that set up, or at least doesn't have the ISO to begin work in that sense?
No, I still have mine set up.
Okay.
Also, did you receive my message?
Was it an email or a text message?
No, I just sent you a chat in Zoom.
I did see something very briefly. I don't know if it's
Okay.
displaying. I don't know if it's displaying on the screen while I'm sharing the screen.
No, it's not, but you can just check it when you get the chance.
Okay.
All
All
right.
right. All right. Thank you for calling that out. So we have a couple of interests when it comes to uh, disks as devices in the I/O continuum, and basically, I hope you've had a chance to poke around in some of the folders here, but there is a series of topics in YouTube by a particular channel called Tech Videos, and they provide some relatively straightforward concepts and ideas. You know, it's not a very granular or very theory level that you're going to find like in your textbook, but it does explain in broad terms what certain concepts are about. My expectation is that you'll watch each of these because the I/O continuum is implemented or manifested or maintained through a whole variety of technologies and methods. And you know, we've talked about how disk defragmentation helps improve performance and reliability, and so here's an explanation. RAID. This is the most important reference or resource for you when it comes to understanding the different levels of RAID. So this short video is very good at explaining the differences between RAID, what the advantages and disadvantages are for each, and that's just you know, a very efficient way to understand redundant array of inexpensive disks, RAID. The NAS versus SAN, if you have a RAID disk array on steroids and you connect a network to it, about 20, 25 years ago, network attached storage entered onto the scene and provided an extension of file system resources to operating systems of all types. And what we want to do is help everybody understand the difference between network attached storage and storage area networks, again, on just a very broad level. So you understand the functional differences and the conceptual differences between those two technologies. And then last but not least, no file system reliability measure would be complete without some manner of discussion about backup methods. And essentially, backup capabilities are built into an operating system attributes and criteria on the design level, just as extended attributes for the file system allow for journaling and logging, that kind of thing. So I wanted you to have some basic understanding of backup methods. There's, you know, a full backup, there's an incremental backup, and a differential backup. And those would be the three types that you need to know explicitly. And each of those are covered in here where it explains the differences between those. Are there any questions about the resources in the I/O continuum persistent enhancements by level folder?
No.
Okay, great. So let's get back out here. So your lecture slides by author. What do I expect you to know in the lecture slides? Wow, there's a lot of lecture slides. For this, so you may recall in module 2, you only had 2 chapters in the textbook to worry about. I think it was 39 and 40, and now it's like 37 through 40 or 36 through 40. And those are different lectures, but basically there are different concepts in here about file system API, file system implementation, what's called a fast file system that has to do with performance file systems, right? And the algorithms that are associated with that. Log structured file systems, that gets into journaling capabilities with the attributes related to journaling. OS crash consistency. How do you handle crashes? There's a page file in virtual memory in Windows. The larger the page file and the more dedicated the hard disk space, the better the capture of crashes. So there's content in the RAM and content in active page file memory on the disk that's written to a log, basically a crash log. Of course, those are things that all have to do with enhanced reliability, enhanced resilience, enhanced redundancy. One thing that I did not go into a lot of detail in any questions so far about the different lecture slides? You just need to be familiar with the main ideas in those slides, and some of the stuff that you're going to see there is also in the study guide. Okay, so one of the things that we talked about in the study guide, made brief mention of in the study guide, was something called dynamic disk. Have we discussed dynamic disks yet?
I don't believe so.
Okay. So in Microsoft, in order to add some of the resilience and journaling enhancements, backup capacity, essentially when you get into the weeds on the slides for those different chapters and all of those different lectures, it's going to cover some basics about how a disk starts up an operating system. There's something called a boot sector. Has everyone heard of a boot sector before?
No.
Okay.
No.
Well, it's often called a main boot record. Main boot record, MBR. It's a section of the disk near the front of the disk. So when we say front of the disk, we talk about closest to the spinning axle or closest on the inside track. That's where the disk sectors start, toward the inside, not toward the outside. Further outside the spinning disk, the data sectors are stored. You have different, the performance drops off, and because your startup is closely tied to, and the loading of your operating system is closely tied to performance issues, those are usually loaded toward the inside of a disk track. In any case, in Windows, we have a disk management capability. And can everybody see the term basic here?
Yes.
Yeah.
So a basic disk is a physical disk that is initialized as a basic hard disk for use with respect to the implementation of a file system. So you go about the process of building out a file system. After the physical disk is initialized, then it's partitioned. Then once it's partitioned, then it's formatted. The format establishes a size of logical data chunks we call inodes or allocation units. This is all ringing a bell, yes? Hopefully.
Yes.
Okay. So if you look at a disk and you look at what loads first, there's this main boot record or MBR or a boot partition, right? So a bootable partition is a partition that has the OS startup operations and programs at the front of that logical volume, that logical disk drive, and it's the first thing to load. It's stored in the MBR or boot sector of the drive, the very top or inside spindle of the drive. And so basically, if you can just imagine a disk, the outer level, it's toward the inside spindle, where the first disk sectors closest to the spinning axle are on a disk. I'm sorry I don't have an image right here, but basically, if you've seen the other pictures of disks, everybody knows what I'm talking about, right? Spinning disk. Or would you like to see a picture of the disk? Your choice.
Yeah, see the picture.
You'd like to see a picture?
Yeah.
Okay. So, now let's look in here. Oh, all right. So that downloaded this thing. I was waiting for it to show up on the screen. All right. So let's see if we can find. Can everyone see this?
Yes.
Okay, so your traditional hard disk is a series of metal platters that are coated with electromagnetic material so that you can encode magnetic spots and then leave them blank. And that corresponds to the ones and zeros. The heads that read this thing are like the arms of a record player, and they're normally parked out here along the side, and there's an arm for each one of these surfaces. So when you pry open a hard disk, you see this arm with a magnetic head, a little dot, a little element, metal element on the end. And when it turns on and it starts to spin up, basically the inside section of the disk is what you would consider to be the initial sectors of the disk. So essentially, when you're first loading your operating system, it's going to swivel in here, and connectors are going to load in the operating system, and then you have your either a terminal prompt or a GUI, so that it starts up services. All those things load from here. In a basic disk, the main boot record is stored here, and it's stored in a traditional manner, using the attributes and file system criteria for main boot records and boot sectors. And so that's what a basic disk is. Okay. Basic disk includes the first sections of the operating system that load. Now, I want to tell you that disk technology has advanced considerably, and there have been new designs along the way. I'm referring to the legacy disks, when they first came out, that's how they worked. As technology changes, there may be some differences in terms of, where the heads park, as opposed to, just on the side of the disk. Disk stops spinning and the heads are parked. And that's usually what happens with a laptop hard disk. There's extra features that are built into laptop hard disks to make them more resilient. But I want you to be aware that the industry and the methods and the engineering are just marvels, and they can change from time to time. But basically, I want you to understand that the first sectors that are read by the heads include the operating system, what's required to run and load the operating system. And those are stored in the first sectors of the disk. Now, if you right-click this and convert it to a dynamic disk, an interesting thing happens. First of all, if you do this, I'm doing this on my laptop, so I have a laptop hard disk, and I can convert a basic disk into a dynamic disk. The dynamic disk converts the main boot record or boot sector, and it stores it in a database format. So it puts the main boot sector and the boot record, and it sort of there's a metamorphosis. The basic criteria and attributes that are normally part of a basic disk are sucked into this database, and the database has multiple copies of that information, more than one copy of the boot sector information, more than one copy of the main boot record and the file system table or the file table, right? More than one copy. And it stores these in different locations on the disk. And that makes this, in theory, that makes this hard disk more resilient. And it allows the operating system to do more important things when it comes to crash management, disaster recovery, all that kind of stuff. There's only one problem with that approach. All right, well, let's talk about the other advantages. Most hackers are going to try to inhabit the boot sectors of a disk because they're the first read when the disk starts spinning. So when the disk first starts spinning, if a hacker embeds some code in the main boot record or the boot sector, it's going to load almost immediately. And that's good because they're always lurking around in the background, right? So imagine the surprise for low-level algorithms that were created by these super hackers to infect the boot sectors of a basic disk. Imagine their surprise when they find out that, oh, nobody's home, right? There is no boot sector. So they're using low-level commands to infect the boot sectors in the first data elements of the disk, and there's nothing there. Nobody's home because the dynamic disk stores them elsewhere. Why do you care? If you're doing disk recovery, if you're doing data rescue, if you're trying to unerase deleted data, a lot of disk utilities are going to be geared to work with basic disk types and not dynamic disk types. That's the first problem. So a lot of bare metal backup recovery software packages are going to put the boot sector software and applications right back in where they would expect to put them with the basic sectors. And if your disk is formatted if it's converted to a dynamic disk for better resilience, then, well, you have a problem because the disk utilities don't know how to interpret that. Why else do you do dynamic disks? Well, Microsoft wanted to provide for some redundancy on a software level. Put another way, you're reading about RAID, and RAID is normally implemented with hardware, with a disk controller that has additional firmware and additional memory, and there's actually an embedded processor in there, right? Like a miniature operating system. You remember this from last week, yes? Please, everyone?
Yes.
Okay, good. So what you have is a case where sometimes it's good to be able to work within an operating system to do redundancy with disks. What am I saying? If disks are dynamic, the other benefit, the other factor that makes a dynamic disk more resilient is that once you convert a basic disk in a Microsoft operating system context to a dynamic disk, well, then you can take two dynamic disks and form a RAID 0 stripe. And the use of that term is deliberate. So a RAID 0 is called a stripe, where you put segments of data on each of the disks, and it looks like stripes. When if the data that was written to RAID 0 disk set were color coded, it would look like you're burning stripes across the multiple disks, right? So a RAID 0 stripe. You can do a RAID 1 mirror. So a mirror is an exact duplicate of the data on two or more disks, right? So mirrors, even numbers of disks. You have to have even numbers of disks to do mirrors. You don't have to do even number of disks to do stripes. You have to have one extra disk if you're going to do RAID 5. So there's all these extra things they talk about in the resources, and you need to spend some quality time digging into that so that when you get these questions on your assessment, you know, we're not going to cover all this in class. This is all very basic stuff, and it's all very, you know, I would say some of it's a review for computer architecture, but in any case, you can form a disk, a RAID 0, a RAID 1, or a RAID 5 array with dynamic disks in software. Now, software level RAID arrays work like hardware RAID arrays, except that they're in software, and so there's a performance hit. There's actually some overhead associated with software level RAID. Why would you do that? Well, there are cases where you want to be able to just add extra disks. How many gigs do I have in my C drive right here?
336.95.
Yeah, 236 gigs. That's not a very large hard disk, is it?
No, not much.
Not really. So let's say that I'm using this business laptop for a time, and it's got really important sensitive information on there, and I run out of disk space, and the operating system needs more breathing room, and I have to load more applications, and I have to store more data, but I'm stuck. If I convert this to a dynamic disk, I can basically create, and I'm not going to do it because once I do it, watch what happens. If I go, okay, that's going to say the disk that will be made dynamic are shown. It'll convert. If you hit convert, it's going to warn you, and it's going to say, are you sure once you do this, you can't go back. You cannot revert back to basic disks easily. You can convert back, but it's messy, and you can destroy like boot sectors and stuff like that. So it's not generally recommended, and usually there's a warning there. But let's say that I convert this to dynamic. I can add a second disk here. I can make that dynamic, and then I can span the disks. Spanning the disk means I can add the new disk data sectors to the existing C drive. So I can span them, making the C drive, let's say I had a 500 gig D drive, disk 1 instead of disk 0, the physical disk. And I format it, and I use all of that space. I don't have any recovery partitions, but I use all of that for an NTFS volume, and then I convert it to a dynamic disk just like C drive. I can take C and I can take D, and I can right-click them and form what's called a span, which is JBOD, just a bunch of disks. I can stitch the second disk storage space onto the end of the C drive, and that second physical disk thinks it's part of C drive right here. Now, here's the fun part. If I pull the physical disk out of the laptop and the physical second disk, disk 1, out of the laptop, and I mount them, I connect them in a disk docking bay, and I start to read them, I'm going to have problems because the two of these have to work together. The two disks have to work in tandem, and if I lose either one, I lose all the data. So if I lose the disk 1, I lose all the data on the C drive in disk 0. If I lose the C drive in disk 0, then I also lose any data that was in disk 1, the D drive. Once I make it a spanned volume or a JBOD, just a bunch of disks, I just stitch them together. A better solution would be to partition an exact size, 236.95 gigabytes, and then I have disk 1, I have unused disk space, but I have a disk drive D. This is dynamic because it was converted. Disk 1 is dynamic because it was converted. And in the operating system, inside Windows, I can create a RAID 1 mirror. And so everything that's in C drive is duplicated to the second disk. Now, the operating system only sees drive letter C. There's a second physical disk, disk 1, and a logical volume, what we would call D, except when you create a RAID 1 mirror, it just takes this and that together. A lot of times you have to do this intentionally up front when you're building your system out in the first place. If I try to do this after the fact, it may wipe the contents of this disk in order to be able to form the RAID 1 mirror. Every technology is different. Every RAID controller works differently. Hardware RAID controller works differently. Software RAID solutions work differently. Sometimes you can salvage and migrate the data into a RAID 1 set. Sometimes it has to be wiped and you have to basically have a backup. But I wanted you to be aware of this particular kind of resiliency. There's very brief mention of it in your study guide, but I want you to understand that if you go back, if you go into dynamic, it's hard to go back. There are advantages in terms of software level redundancy and in terms of resilience with the boot sector, because there are multiple sets of those stored in a database that's bulletproof or supposed to be bulletproof. The disadvantages are your disk utility and disk recovery, data recovery tools for forensics or other things don't work. And this causes a problem for forensics. If you're doing digital forensics and you want to rescue the contents of a dynamic disk and you're using a standard disk utility, the disk utility may not know how to interpret the fact that it's not a basic disk. So I know I went into some considerable detail there, but does anybody have any questions about basic versus dynamic and the context there? And that's Microsoft only. Linux doesn't do this. Mac doesn't do that. Mac does something different. So every OS has different flavors of making their stuff more resilient, more redundant, higher performance, more accessible across the network, across the cloud, across the internet, across a wireless, right? Okay. Where are we? I'm gonna close this. So in our, just be sure that you take some time to review the key concepts, and there's I got to tell you, there's quite a bit. You don't have to know it all, but you have to know the main ideas, right? So there may be some very basic information about the file system API, and if it's not in the study guide, you want to make sure that you are looking at the file system lecture slides. I can't cover everything. This is a very large topic. This module is kind of like a super module, and that's why we broke persistence down into 2 parts. And I want you to know that, yeah. So file system API, right? So there's basic information about inode numbers, file descriptors, what links are, and it's all pretty self-explanatory. You should have an idea of what an inode is based on our previous, is there anyone that doesn't know what an inode is based on what we've talked about before? What's the term that we use for Windows? Is it inode?
Allocation unit.
Allocation unit is correct, yes. Okay, yeah. So yeah, this information is useful when you have crashes, you have metadata for the file and the file inode locations, the disk sector locations, and all of the basic lower level operations are important to understand. So, I should be able to ask you a question about basic file API commands, and then for you to pick out of a list that read, write, and seek are some of those file APIs, Okay, so I'm not going to make this very difficult. I'm not going to pick some arcane, weird factoid out of the textbook. But if it's in bold letters on the slide, you need to know something about what it is. Okay, so read, write, and seek are low-level operations, right? And it has to do with the file API, file system API. So I am going to draw just a couple of very basic questions from each of the slides. And all right, let's talk about our solution. And one more thing, in our study guide, you will notice that there's a very important section that has to do with Linux integration in the enterprise. And you have to know that cold. You're going to have to know each of the four different ways. There are 4 different methods that you can use to integrate Linux and operating system clients with Active Directory domains, and they each have their advantages and disadvantages and limitations, right? So if I go and skip down to section K here, whoop. All right, so some of this is text summary of all the slides and videos of the other stuff. Where is this? Linux. Oh, I think it was there. So Samba is one of the methods that we use to integrate Linux into a enterprise environment. And you implement Samba on top of NAS. And so what you're doing is network share level access, small message block or server message block, RPC, remote procedure call, and CIFS. It's something interface file system. Yeah. So basically, there we go. Here are the 4 approaches. So this one's kind of a favorite of mine, and it's not very widely advertised, but does everybody know what Unity is?
Unity web player or something like that?
It's not a web player. So you have a virtual machine running a different operating system. Let's say you have Linux in the virtual machine operating system. I'm going to demonstrate here. So I have my server here. And so this is my local virtual machine, server 2019, running on my laptop. And you can basically complete everything that has to do with the Windows subsystem for Linux implementation and the solution using just your local server. All of the commands, all the steps that you follow work the same on the local server level. It's a long story, but basically it's kind of a simulation. What we're doing for the solution is a simulation of Linux integration using domain security groups. However, the Linux subsystem for Linux is completely self-contained. It's virtualized. It's in a sandbox, and so it's not really a true way to integrate Linux. You can integrate Linux functionality, and you can run Linux programs, and you can control the permissions on Windows systems that are running in the enterprise. So that's one way to do Linux in the enterprise with Windows subsystem for Linux. But you also have to be mindful of the security, the permissions, the privileges, and inheritance, all that stuff, right? and RBAC still matters, which is why we're doing the solution this way. You don't need the system on the campus, your virtual machine that you access through Google Chrome to finish that. But I have here calculator running. Everybody see calculator running?
Yes.
Okay, so let's pretend this is a Linux machine and I'm running a special scientific calculator that's a really cool open source scientific computing application calculator in Linux, right? And I switch the view to seamless mode. In VirtualBox, it's called seamless mode. What I'm doing is saying I don't want to see the virtual machine, I just want to see the applications that are running, and I want them to appear on my host desktop as if they were running on the host. Now, are we really integrating Linux into the enterprise environment when we do that? No, we're incorporating Linux capabilities in the enterprise environment. But here's what happens when you go and use Unity, or as VirtualBox would call it, seamless mode. I have to remember my host combinations. That's going to be the right control key and the letter L to go back. Otherwise, I get this freakish result where applications from a different system are running on my host desktop. And when I go to copy and paste, you'll see in just a minute, I'm going to switch, right? Can everybody see?
Yes.
Okay, so what you see here is the calculator. But that's not the calculator running on my laptop. That's the calculator running inside my virtual machine. And it could be just as easily a Linux machine, okay? So one of the ways you can incorporate Linux file system and file system capabilities into an enterprise environment is to run virtual machines and then use Unity or this. Now, here's the problem. Let's say that we're going to do 45 times 6, and I have 270, right? That's my answer. And I want to copy this into a spreadsheet. Are you with me? What do you think happens when I try to open a spreadsheet here and paste this into the spreadsheet?
It won't carry over. It won't be able to paste.
That's correct. If I go here and then paste, oh, evidently I have drag and drop and the clipboard enabled for this virtual machine. And there are many cases where the clipboard and copy and paste is not enabled for security reasons. But all right, so normally when you try to do this, it doesn't work. And what you suspected by that rhetorical question is normally the case when you don't have those things set up. But that's one approach to running this way, okay? So if I want to get out of here, I have to remember Control L. And oh my gosh, it's stuck. Whew. Worried there a little bit. So it can be kind of touchy or finicky. That's one method. Another method of integration is to integrate Linux functionality into Windows and vice versa. So you use Windows subsystem for Linux if you're in the Windows universe and you want to run Linux stuff inside Windows. If you're in the Linux universe and you want to run Windows software inside there, you use Wine. And this is probably the most challenging approach of all because Wine and WSL are middleware. And so that's not the ideal. Samba is this other thing. So you run an application client. It boots, it fires up when you log into your screen on Windows, and then it authenticates. It provides the authentication and access to Linux legacy resources across a network, right? So that you can make use of Linux file stores. Now, one thing that happens is that when you copy files between operating systems, they lose their attributes. So an NTFS file that's copied into a Linux environment is going to take up ext4 file attributes, or if the volume is formatted with file allocation legacy FAT or FAT32 file systems, then most of those attributes are going to be stripped off. So switches to trigger log settings, auditing, you know, inheritance, a lot of those things don't come across when you drag files back and forth. That's one of the caveats of this. The fourth option is to create your own forest. You create your own realm in Linux, and then you create a forest from the Active Directory side. Well, when you create the first domain, you actually create the first forest as well, and there's some information about how that works, and it should be pretty self-explanatory here. But I wanted you to make sure that you know this. This is really important to know. When you create a first domain like we did, groovy.net, that's actually also the first forest. So groovy.net is the first tree in the forest. If I had students.groovy.net, that would be a child domain. If I had teachers or faculty.groovy.net, that would be another child domain. Those are branches off the same tree. It's still groovy.net, but they're child domains from the parent domain. So it's like tree and branch metaphor. It's a way of thinking of it. You can have multiple domains in a forest. In Active Directory, there's a primary domain, the first one that's created, but then you can add other domains and have a series of trees, domain trees, that comprise a forest. Well, what am I saying here? Forests or domains can trust realms. So one of the ways to do this, if you're going to go big with Linux, and they probably do this at the national laboratories or at research laboratories for Fortune 500 companies, they probably have a realm. It's Linux equivalent of a domain, and there's a trust that's set up with the domain, and you separate church and state. This is the hardest to do. It takes the most money. It is the most difficult to implement. But if you have a huge commitment to Linux and using Linux, and you have to interoperate with Active Directory domains, it is the preferred best method. You just have to be willing to invest all that in the infrastructure. Okay. So this is on each system or host. The rest of these are on the system and host level. So this is the only one that's like large scale, go big or go home kind of internet or enterprise solution. You may hear the term federated trust. That's another way of implementing this kind of thing. So you'll see stuff online about federated trusts and setting up federated trusts between domains and realms. That's what's going on there. So if you hear the word federated or the word trust, it means federated authentication or trust. It's talking about this kind of setup right here. If you have a client that runs on Windows and it allows access to Linux servers, file servers, web servers, email servers, security appliances, cybersecurity tools and analyzers, that kind of thing. A lot of times you get on there, you can basically drag and drop like you're working in File Manager because it has a GUI interface. We're going to be using this one because sooner or later Microsoft is going to get it right, and you'll be able to do a lot more with Linux in Windows. That's kind of their modus operandi. That's why we've included it. And this has been around a very long time. So which one came first? Wine and WSF. Wine came first. This came next. Well, yeah. Then this came next. And then this came last. This is the latest, greatest. This is what you do if you're like industrial strength kind of things. Any questions on the Linux integration options? There are 4.
No question.
Okay. So you're going to open your local server. You're going to access all of the materials online, but instead of mapping a drive letter to Virgo, what you're going to do is use the link to go to So in simplest terms, you're going to open up your browser in your server on the local machine. Then you're going to go to Google, and you're going to type in this string: install WSL Microsoft Server 2019. The first or second reference that comes up is direct from Microsoft, and it's a May 12th, 2020 reference. You click on this link, and you follow these instructions. I'm hoping I can get on campus today, and if I can, I will reboot the hosts and get the virtual machines running. And the method that's already in place is actually easier and quicker to do, so I'm going to try to make that trip and see if we can get our systems back online. If we can't, I'm going to post this link in the assignment on Blackboard, so you can just click on this link, and if you reference Blackboard from within your server, you can just click on the link, and then it'll bring you. Okay? Any questions?
No, for me, I have done like all the steps. I have reached step 9 and 10.
Oh, excellent.
And after that, the system broke.
Good. Okay. Well, we'll try to get the system going so you don't have to redo those steps. So I'm glad you shared that, so I understand that you have a lot of work that you don't want to have to do over again. So that might give me some leverage with the campus facility folks. I have to clear the screen and the recording to start another class. Did anybody have any quick questions before we end?